Hello, how are we doing today? I apologize if the lighting is not the best. I just don't really have the perfect spot to do these videos in my home. Forget that, it doesn't matter. Today, I want to speak with you about the scientific method. If I had creepy background music, that's where I would play it. So I would say scientific method. Right, okay. What is the scientific method? You've heard it, maybe you've heard of the name of it anyway, but you're not exactly sure what it is. Well, in these next few moments, or minutes, whatever you want to use, I will explain that to you, and we will go forth and do what we do and figure it out. All right? So, in scientific method, there are 4 steps. 4 steps. Now, you could go on to YouTube and you could type in scientific method, and you can see how some videos might say 6 steps, or they might say 7, they might say 3. All right. All of them have the same general structure, maybe the skeleton, if you will. However, just the specific points, depending on how in depth or how deep you want to take something. So for this class, for you guys, it's a 4-step process. All right. So we have observe. You probably can't even read my writing once I experiment, and then conclude. 2, 3, 4. All right. 4 steps. Observe, hypothesize, experiment, conclude. Again, I will just leave this up here for a moment if you want to pause the video just to write those down, because, again, my handwriting may not be the best. All right. Well, let's start at the beginning. Observe. You observe something in nature. I'm just throwing out various examples. You're thinking, it's fall time, leaves outside, they're starting to fall. It's October 1st as of recording this video. And you're thinking, boy, that tree is still green. Like, there doesn't appear to be any yellow or gold. And so all those leaves, they're fine. You would never know it's October. But then the one right next to it has a lot of the leaves are turning color. A lot of them have fallen already. So you're wondering, you're observing, why does that tree have leaves that are falling already, but the very same tree next, or the tree next to it, doesn't? Maybe this. Maybe you're curious as to, I wonder how I can get water to freeze fastest into ice cubes. You're thinking, boy, I like ice cubes with my milk at dinner time. I like ice cubes with my water when I'm at school. You know, I just like ice cubes in everything that I drink. How can I make ice cubes faster? All right. And you know what? The list can go on and on. There are thousands of things out in our world that you can think about. Well, for the purpose of this video, I am going to walk through, and my observations are this. I really like board games. I wonder which one is my favorite. Okay? This is a good one. Paladins of the West Kingdom. I may or may not have chosen that because of the name. However, but is it as good or not as good as Crusaders? Thy will be done. Again, choosing that game may or may not have anything to do with the fact that this video is for my fellow paladins. So you observe, you notice things, you wonder things, and you think, boy, why does this, or how does this, or because this happens, does it mean that this is going to happen? You're observing, you're watching, you're looking. Number 2, hypothesize. That's where you take all of that information and you bring it down into one question. One thing. Is Crusaders a better game than Paladins? That's my hypothesis. In fact, no, let me rephrase that. I'm going to say that, yes, Crusaders is a better game than Paladins. That's my hypothesis. I'm guessing that game is going to be better than the other one. Your hypothesis with the ice might be, if I just take water out of the tap, just regular temperature tap water, fill up my ice cube tray, put it in there, that's going to be the quickest freeze time. Trees that are falling, who knows? You know, peas versus carrots. Which one do people like the most? And you might hypothesize people like carrots the most. That's fine. Your hypothesis can't be a mistake. It might be proven wrong, as we'll find out, but it's not a mistake. Because you have to have a frame of mind. You have to have some place that you're starting when you're talking about scientific method. You have all these things, this cloud of stuff that you're observing, and you funnel it down to one question or one idea. That's your hypothesis. Well, now we have to be scientific about this. We have to be scientists, in essence, and we have to experiment. We need to figure out, well, with my ice, I put one tray of regular tap water in there. Next to it, I put another tray, but instead of regular warm tap water, I make it as cold as the faucet will pour it out. So now I have 2 trays in there, put them in at the same time. One was regular warm, like regular luke temperature, and the other one is cold water to start with. And then I time them to see which one freezes faster. I might need to play this. Now this game is 2 to 4 players. Alright? Let's say I play it 10 times. I have 2 other buddies. So there's 3 of us. And we play this game, we play it 10 times. And each time maybe write down some notes or some thoughts. Alright? Then the next day, or the next week, whenever my brain's recovered, I take this and I play this game. Same 3 guys, and we play this game 10 times. I've been doing experimenting. I've been saying, I've observed this. This is my hypothesis. Now I'm going to test it. I'm going to experiment. I'm going to figure things out. Going back to the ice. You could do multiple things. You could make salt water versus fresh water. You could do various temperatures. You could do location in freezer. There are so many different ways that you could experiment. And what you do is you record that. You write all that down. And so that as you're doing these experiments, you're coming up with data. You're coming up with information based on your experimentation. All right? We've observed something. We've made a hypothesis. Basically, an educated guess saying, I think this is what, and you fill in the blank, whatever it is. Now you've experimented. Now you've done experiments. You've got a whole notebook worth of stuff. You conclude. All right. Now, in my gaming life experience, I think that Paladins, this game, is actually slightly better, just in a general overall sense, than Crusaders. My original hypothesis was saying the other way around. It was saying that Crusaders was better. Now, that's my conclusion. Was my hypothesis incorrect? Sure, it was. But that's not the point. The point was that it gave me some place to start so that when I experimented and I did all these testings, I could learn something. I could figure out, well, which one really is better. So then when I come to the conclusion, now I at least have some hard, fast evidence that tells me, yes, Crusaders was better or Paladins was better. I want to go back now and I want to do more testing. All right? And I would do this. I would maybe each of them plays up to 4. So I want to get 4 people together. The same 4. Play each of them twice. And then play the other one twice. So there's 4 game plays. And so you've got the same number of people, the same people, and you're doing all things equal. The only thing that you're changing is the game. Again, you're doing more data, more testing. So it can kind of go around in a circle. You can observe something, you can make a hypothesis, you do all this experimenting, and then you make your conclusion, and then, well, no, I'm not exactly sure if my hypothesis was correct, or I feel like I just don't have enough information. So I can go back now, and I can either change this, or I can go back to this step and do more experimenting. In your class, this class, you are going to use the scientific method. I'm going to give you a couple different options. One is that you're going to talk about soda. All right? You're going to make some observations about soda, and then you're going to hypothesize that whatever soda you choose is the most popular, or people like this particular soda more so than any other soda that they can buy, or however you want to do it. Then you need to do some experimenting. You're going to write up different ways that you're going to test that, how you're going to document that, and then you're going to conclude. You're going to come down here, you're going to get to the 4th step, and you're going to conclude, okay, based on my experimentation, my hypothesis, which was whatever, is correct. Or, based on what I saw, my hypothesis was actually incorrect. In fact, it wasn't even close. That's okay. That is okay, because that's what science is about. That it's okay to fail. It's okay to not get it right, because you're not doing necessarily bad science. What you're doing is you're weeding out all of the stuff that doesn't matter, and you're coming up with something that's good, that's important. So you could do soda. You could do cars. And you might hypothesize that green is the most popular color of a vehicle out there. Or you could say there are more trucks than there are cars. Maybe you want to go trucks, cars, and minivans, and then a 4th category, which is just all other cars. Maybe you want to do the color of the car. Who knows? You can do whatever you want. But I'm just giving you some ideas of things that you'll be able to do. When we come back to class and we're together, we're going to figure this out, and you're going to have a write-up, and you're going to know what you can do. But you get to choose the topic. But the scientific method, that's what this is about. You're going to observe something. You're going to wonder. You're going to think about it. You're going to see it. Secondly, you're going to hypothesize about it. You're going to make a guess as to how does this work. This is what I think is going to happen, or this is the reality based on what I've observed. Thirdly, you're going to test it. You're going to write experiments. You're going to do these experiments. You're going to follow up, and you're going to do all this data collection, etc., and then you're going to make a conclusion. Was my hypothesis correct? Incorrect. Do I need to change my hypothesis? Do I need to do more testing? 4 things, scientific method. All right. And just so you know, the this Crusaders game, in all reality, I have only played it one time with other human beings. The Paladins game that I was saying, to be honest, I have not played this with other human beings. I got it. I'm excited. I've set it up and worked through it, but I need other humans to play. So as soon as this COVID stuff is done and we can actually have normal interactions with people, then yeah, maybe we'll get together and play it. But until then, happy scientific methoding. Is that a thing? It is now. And so, thank you for watching, and we will see you next time.